Our focus standard for today's lesson comes from grade 7, Ratios and Proportions, standard A1, Compute unit rates associated with ratios. Our topic today is from Proportional Relationships, Comparing Unit Rates. Our essential question is, how does calculating unit rates help us make comparisons and predictions? Please take a moment, pausing the video if you need to copy down the topic and essential question, along with today's date, side of your question column, and your note column, and resume the video when you're ready to begin. Let's go ahead and start with some important reminders about rates. So ratios are how we calculate rates, and they compare two quantities, usually given to us in some kind of variable form, by division. So there's three ways that you've learned to write ratios over the years. You can say A to B. You would read it the same way, A to B, and use the colon in place of the word to. Or A to B using the division bar, or A per B might be familiar as well. So we are going to focus primarily on this last way in our unit on proportional relationships using division. But these are other methods you have learned to write them. You may also remember from 6th grade calculating unit rates, where we find the ratio for two quantities, right, like we're doing up here, but this time with a denominator of 1. So let's go ahead and start looking at some ways we apply that. So the most common application of unit rates is while you're shopping, when you're comparison shopping and calculating the cost for one item or one unit of measure. So here we're looking at two ads I found for Honey Nut Cheerios. This is a sale that Fred Meyer is having, and this is a sale that Target is having. So we're being asked to calculate which has a better sale and to use the unit price per ounce to determine that. Well, here they're selling a 12 and 3/10 of an ounce box of Cheerios at Fred Meyer for $1.79, and at Target you can get two boxes that are 20 ounces for $7. And both of these, although the packaging is different because they're different sizes, are Honey Nut Cheerios. They're just different sizes. So we want to figure out which store is having a better deal. You may remember from 6th grade that this word per is really helpful in setting up ratios, and in fact it tells us our numerator and our denominator. So we're going to use price in the numerator over the number of ounces for Fred Meyer's deal and for Target's deal to determine which has a better sales price. So let's go ahead and just set that up as we discussed. So what I want you to start out is find a spot in your notes to be able to calculate it for Fred Meyer. Again, we're using price per ounce because this is our key words here, numerator over denominator. And we're going to do that for both Fred Meyer and Target. And then we want to decide which one has a better deal. Well, with Fred Meyer, it's $1.79 is the price, so I put that in my numerator, for 12 and 3/10 of an ounce. So I have put that in the denominator. And then we can very quickly just divide that. So in any kind of calculator, we can take $1.79 divided by 12 and 3/10. And we have this long fraction, but we really only need it to the hundredths place because we're talking about money. So it's 0 and 145 thousandths. That 5 rounds it up to where it would be 15 cents per ounce. Why don't you try the same thing with Target? I will let you know that I was using the price of $7 for two boxes that were 20 ounces. So I calculated it using 40 ounces was $7. Go ahead, pause the video to calculate the unit price for Target sale, and then let's check back to compare. So the setup was the same as I mentioned. I did $7 for 40 ounces since you get two 20-ounce boxes for $7. I divided that out and found that it was 18 cents per ounce. So in comparing, it looks like Fred Meyer has the better deal, so we want to state that. Something like Fred Meyer has a better sale because it's 3 cents cheaper per ounce. So again, unit rates are something you may remember having calculated in 6th grade, and we'll be bringing them back in our discussion on proportional relationships. Let's look at another common application of unit rates. So oftentimes when we're comparing speed, we can look at measuring distance for 1 unit of time, or vice versa, how much time it took for them to go 1 unit of distance. So here we're talking about the go-kart track at Oaks Park. Nick drove 12 laps in 8 minutes, while Carl drove 7 laps in 5 minutes. Who had more laps per minute? Do you notice that keyword again? There it is, per. This is a good one to keep an eye out for because once again it tells you how to set up your fraction, your ratio. It's going to be laps in our numerator over per our minutes in our denominator. So go ahead and try and calculate that for Nick and for Carl to see who was faster. For Nick, I calculated, as I mentioned, laps over minutes, laps per minute, due to the way it was set up. Since he was 12 laps in 8 minutes, I set that ratio up and divided it out, and got that Nick was doing 1.5 laps per minute. So that is his unit rate, since we're talking about how many laps he did in 1 minute. How about Carl? Well, same setup. He did 7 laps in 5 minutes. 7 divided by 5 is 1 4/10. So Carl, completed 1 4/10 laps per minute. That is his unit rate. So, who's faster? Who had more laps? Well, Nick just barely beat out Carl, and he was faster by 1/10 of a lap. So for our final question, assuming that Nick and Carl don't need to refuel, they have plenty of gas, and they continued at a constant rate, how many laps would you expect each of them to complete in an hour? Well, there's a setup that we're going to do for each of these. Let's take a look. So we're still finding out how many per 1 unit of time, and this time we're moving that unit of time up to 1 hour. But we can calculate hours in minutes. So I set up what I knew about Nick. He's doing 12 laps every 8 minutes. And I want to know how many laps, L, can he do in 60 minutes, since that's 1 hour. So we could scale this up. Same thing for Carl. I have his same setup over here. 7 laps in 5 minutes. How many laps in 60 minutes? So a couple different ways we could do this. You may be familiar with just looking for a common factor. You might ask, do I know something right away that I can multiply by 8 to get 60? And if so, then I can just multiply 12 by that. Right off the top of my head, I'm not thinking of anything. But over here for Carl, in this setup, I do know that 12 times 5, or 5 times 12, is equal to 60. So then I could also just multiply 7 by 12 to keep my ratios proportional and equal. And 7 times 12 will tell me how many laps he can do in 60 minutes or how many laps he can do in 1 hour. For Nick, it may not have been as easy, so another method to use is to cross multiply. So multiplying 12 times 60 and setting that equal to 8 times the number of laps. I think some people refer to this as the butterfly method. So this video is meant to be a refresher on ratios, rates, and looking at unit rates and different ways that we can apply them. Please make sure your notes are complete and come ready to do more calculations with rates in class.